Kia ora katoa. Welcome to the product showcase for January. Yeah, it's been busy couple of months with a little bit of downtime for the holiday break, but it's good, and I'm excited to show you what we've been up to. Jumping straight onto the first project, the Wildlife Watcher. So just for a refreshment for everyone. The idea is to have easy to use smart camera traps that have adequate image quality, they have a reliable motion sensor, and they have AI on the edge so that it can accurately identify the species on the device. And you can configure and test the device through a mobile. At the end of the day, it just provides the timely data insights rather than the raw footage. And it can be out in the wild for acceptable battery, acceptable time, and it's not crazy expensive. That's a big list of ideas and big list of dreams, but it is slowly coming together. So since the last time, we've been busy, and here are a few of the milestones that we have reached. You can see on the bottom right, we've been partnered with Kamahi to get the PCBs assembled. So they have been amazing with all the different pieces and electronics and shortages worldwide and finding works around. So highly recommend them. They put together 30 boards with all the electronics, and we have them now here. And Charles set them up with all the firmware and tested them. Yeah, that's been nice and easy. So we have the 30 assembled boards now with us. We are working towards having a house for those 30 pieces of electronics. So working on the case, iterating over them. Carl has been really helpful with the 3D printing, and Nick from Rewild has been amazing with going over through the design and through all the different pieces that we need to put together. So at the moment we have 4 3D printed cases, and we are holding from making more cases until we really test them on the field and we make sure that we got the design right. We've been busy also with the mobile app, with lots of different people helping on the mobile app over this couple of years that we've been working on it. We finally reached the point that it is available on iOS and Android for testing. So it is a major milestone to be able to have users actually testing it and connecting to the device. And then we have the toolkit for selecting different models that you can run on the camera. So it makes it easier for, at the moment, the development side and testing. So we have a list of different models that we can test. And in the future, it's going to be incorporated onto the mobile app. So that's a big overview of the milestones. And I think that when I keep on saying there has been a lot of work behind the scenes, and we are finally getting there, and I feel like it's always almost there. So I really wanted to capture a bit of the journey that we've been having, especially on the electronics and on the cases, and just to give you a little bit of a flavor of the evolution of the project. So on to PCBs and cases. First prototype that we created, WW100. It was a mix of different electronics just put together, tried to make something work really. Try to get those animals that are usually missed from camera traps, like invertebrates and other animals like lizards. So using different motion sensors and trying to run machine learning on the device. And it was communicating with it so that you can turn it on and off. We initially started with no case, so that just early days with a piece of cardboard, really putting it upside down with a manual triggering mechanism with USB battery bank. And yeah, that was where the early days. Then we needed to have a case so that it can be set up for a few more days out in the wild rather than just an evening. And started to work on the also communications of the device with a mobile app. So we needed to have a different device that communicated with the actual camera and with the mobile. So it was a bit of yeah, not ideal, I guess, situation. That's the outside the cover of the mobile comms module that we used. So you need to carry these two things into the field. The camera, as you can see on that image, started to record some of the wildlife, and it was really promising, and it was a really good milestone that we hit. It is possible to use this concept. It is possible to create these cameras, but we needed to do a lot of research and development to try to streamline the whole process. At the time we were using these C batteries, quite heavy, and that we needed to make sure that we use for keeping the device running for longer than a day, really. So we went to the lab, but like mostly I just want to say thank you to Charles. Charles Palmer has been instrumental onto every piece of electronic that goes onto the Wildlife Watcher and also the code. So yeah, big thanks on to him. He started to play around with different electronics and to see how we can streamline the whole process. So came up with the WW500A, and guess what? There is going to be more. So he printed that new PCB, and the shape, it was perfect for that case, that more of an industrial kind of case, and that it was watertight. So we're like, okay, at least for now it will work. And we started to test it, and the case, it did its purpose, but it wasn't really easy to connect to it. It wasn't really like easy to wrap it onto a tree and to set it up out there. So we needed something different. Here comes WW500B. A bit of a different shape onto the electronics. A single case, a single PCB that it could actually communicate with the device, with a mobile. And on the back, you had the 4 AA batteries. So that was a big win, and we needed to have a case for it, of course. We had that case. It was a bit more of a cube almost. And again, it worked well for development purposes. But we wanted to streamline the whole process. So here this WW500C, which is actually 2 boards. One of them, it transfers the power from 4 AA batteries, and the other one, it has the electronics. For that, we needed a case. So the idea was to make it easy for people that are going to be changing the AA batteries, with cap at the bottom that you can just uncap it, and then you just switch the AA batteries and the SD card at the moment. There are options farther down the track to add solar, to add different sources of power. But at the moment, we want to have something out there, something that is not on design as a CAD design, something that is physical. Happy to share that. We do have that at the moment. So that is how the current device looks like. And there is a big piece missing in the middle, and that's the button. We have been iterating over different button materials, and so we will have something that is flexible enough and something that is watertight also. So yeah, just giving a bit of a perspective of all the different mahi that has happened. Yeah, can't thank enough to everyone who has been behind all of this. So you can see on the video there, on the short video, how the A batteries, the tray of the A batteries just come out, and you can twist it and it closes. And next, we need to keep on testing. We need to find out all the different settings that we have in terms of the quality of the images, how it works and how it behaves at night, different mounting tools, different mounting positions. We need to really narrow down the mobile app flow, because we are trying to align it with the cam trap DP, so the camera trap data standards, that it will make it way easier for people to share the camera trap information, the camera trap data. We need to keep on testing the model uploading onto the device and how the model behaves. At the moment, we have a couple of models running on the device, and they're doing well. But yeah, once we set them up on the wild, it will be great to see the actual results from different animals, the target animals that we're looking at. And waterproof. We are in a place where it is usually a rainforest for a reason. So we need to make sure that the devices don't end up as a small water bottle, really. It is crucial. And then we need to be able to communicate this with the users. We need to be able to provide them with the right guidelines, with the right techniques, with the right tools, so that they can make the most out of it and make an impact, really, which is why we are all here together for. And this is how I think summarizes what the mahi that we've been doing. We are just still putting things together, still getting leftovers from previous iterations and testing it and making it work. And I think that that's a really good approach towards conservation, really. You don't need to invent anything completely new. Just use the resources that you have around. Awesome. Any questions at this point? Yeah, from anyone?
I can ask something, which is for me, it's always fascinating when there's a hardware project, because it's very different to a software project. Like in the sense, if I don't need to wait for things to be delivered or things like this. So do you maybe want to touch upon some difference, like some challenges or opportunities that come working with a hardware project?
Definitely. I think that my experience also has been mostly on software. So jumping onto the hardware, there are a lot of logistics that you don't account for. There are a lot of like the physical aspects of it is something that it is presents its own challenges, of course. But thinking, for example, on the software, you can always lock down certain package or version or something like that, so you know that it's going to work every so often. So you can create different versions of whatever software you are using, but you rely on those basic standards packages. When you try to do that with hardware, sometimes you are missing one piece, and then the whole thing doesn't work because you are missing one single piece that you cannot find, or you find a different version, and then again throws the whole project off. So yeah, I think that locking those pieces that make the actual product, I think, is easier on the software than on the hardware side of things. Hal, any thoughts on that? Because you've been working on the 3D printing, so it presents its own challenges there.
Yeah, no, it's nice being able to work in a medium that is so like it's easy to do iterations and it's easy to modify and just print another one. For prototyping, it's been a bit of an eye opener for me in terms of manufacturing that kind of stuff. But yeah, I like those challenges. I think they're kind of like a physics puzzle or they're like a mechanics engineering kind of yeah, kind of like a puzzle. So I really like them, but they can bog you down, so you've got to be careful.
Awesome. Kalindi, passing it on to you on to the next project.
Yeah, hello everybody. We're back with Spyfish Aotearoa, and as Victor said, to remind us after the holidays, and Happy New Year, everybody. The objective is to utilize machine learning and citizen science to monitor marine reserves more efficiently, which may basically mean having a pipeline that, in this case, counts specific fish or species of fish instead of doing it manually and all the steps in between. Okay, next. So what we did in the last, since the last call, I think I mentioned it a few times that we always do data cleaning and it's our one big task. And we kind of decided that maybe our data is clean enough, and this happened mainly because we set a cutoff date and we're like, okay, anything that happened before then, we just say it happened. And from then on, it's clean, and it basically means we can now focus on the pipeline and machine learning and use that data to go through it. I guess with any pipeline, you want to know what's actually happening. So we worked a bit on having a system status page. And so there's two parts to the system status, and one is the errors. So it flags if there's an issue, if something like there's some data comes in corrupt or something, or there's duplicates, things that shouldn't happen basically. And then the health status, which is basically tells us how the surveys are going, how many deployments does a survey have, and where is do we have videos, and are the annotations, do they have annotations basically? And it's all this feeds into the Power BI dashboard because it's a very user-friendly in the sense of seeing, especially if people have the Microsoft suite, which this project has. And so the Power BI, the SharePoint list feed directly into the Power BI now, which means there's less fiddling with different downloads and uploads. And we also included the status dashboard. One very exciting development that happened in the last few months is that there has been the community fish detector machine learning model was launched or shared with the community. And for the underwater world, I guess the above water world had the mega detector for many years. And I guess that's kind of ours. Yeah, if you go forward, I think there's a little description here. So it's basically, it's a model that is just made to find a single class, and it's a fish. So it makes a box around, and it's very good at finding fish-shaped fish. So like the archetypal fish, and it's quite a big effort if you go back. Like it's really a lot of images that the community has collected, and it's from many different environments and so on. So it's a great community effort. Okay, and here are a few examples on some of our data sets. So you see it does a pretty good job at finding fish also in the background and so on. I mean, this is a pretty nice visibility. So, and if you go to the next one, with our Spyfish data, it's interesting because it's from above, and we can see that it's struggling a little bit and missing some fish, but we can kind of fix that with some fine tuning and training, which is our next one. It's planned for us. And then if you go next page, if we reduce the confidence, so we can see that then it also thinks that maybe sometimes some seaweed is basically, it's a fish, but we can see that it's not very confident that this is a fish. So we can see that most fish are actually above 50. So it kind of does create quite a good like a cutoff seems to be somewhat sensible. And now I have a question for you, which is, have you maybe noticed that these images look new, that they are not just from above like we're used to? And in case you're wondering where they come from, it's because we have a new project, which is a collaboration with the University of Auckland, and we are going to assess biodiversity on mussel farms. It's very, like, it's similar in what happens to the Spyfish project, but it's much more smaller in scope. So it's a nice place also to run things fast. And yeah, I guess that's it. And yeah, so on the picture before we go to questions, this is the Bigo platform, and I'll talk a little bit more about it next time, I think. And I talked about it a few weeks ago, so months ago. And it's a really useful tool to quickly review the annotations that the model has created. So it's like we can just select one page and then quickly see that basically this is not a fish, like the top left one is not a fish, and the one's also not a fish, and it really helps our human reviewer review the results of a machine learning model very fast. Yeah, thanks. Any questions?
I think more of a question here, an explanation around where the models were run.
Yeah, so like I usually do a super small test on my computer because it's just like easy to set things up. But then we actually are also, this project is living on Nessie, which is the New Zealand supercomputer. And so we're importing the big videos, and we'll do all the processing there. And we already have like an environment on there, and it does, like these images were created on Nessie, basically, like the annotations, because it's much easier to go through bigger files. Yeah.
Yeah, I think I just highlighted that the data is on the high performance computer, which actually is in the University of Auckland.
Oh, that's true. Yeah. It's
turns
like
out to be.
yeah, okay, because I think it got moved last year to Auckland, so now it's actually very close. But it's the transfer is still it's still I think it's maybe faster than if it's in Wellington, but not much faster, because I think it's human components still that are the most important. Yeah.
Awesome. Any other questions? Cool. Perfect. So yeah, thank you for coming along, and there will be more updates next month. Then, looking forward to that.
Thank you, everyone.